In this video I'm going to take a look at the higher level 2012 U-value question, just the part A. So this is the question here with all our information. We'll be constantly referring back to this. It's got our thicknesses, our resistances, resistivity, conductivity, and all the values are shown here. We'll constantly refer back to that. To calculate a U-value, the U-value, we have to get all the R's or resistances, and we add all those up. We put 1 over the total resistance, and that's going to give us our U-value. So 1 over RT, or RT to the power of minus 1, whichever way you want to do that. Now, in the calculation in the U-value table, there's two things that we can do to get a resistance, which we're going to be adding up. We can multiply the thickness by the resistivity, which is the small r, or the 1 over k. And the alternative that we have to this here, to achieve the resistance, we can take the thickness, which is RT in meters, and we can divide it by our conductivity. So either of those two methods. So depending on what you're given in the question, if you're given a conductivity, it's quicker to just divide the thickness by the conductivity, and if you're given a resistivity, it's quicker to just multiply it by the thickness. So as with every other table, we're going to set out the table as it should be. So we start with our component, where we'll list all our components, our conductivities, whichever we're given, and resistivities, whichever resistivities are given, our thicknesses, and our resistance. The values for each of these here are also given in the question. So K is our conductivity, and it's watts per meters degrees centigrade. Our resistivity is the small r in the question. Our thickness, T, is in meters. Put in the small r here now. And our resistance is the big R, which is meter squared degrees centigrade watts. You don't need to panic too much about these here. It's just so long as you have the values, the figures in these. So if I look through the list, I've actually got 7 elements, so I'm allowing 7 rows to bring me to the bottom of the table. And something that I always like doing, first of all, is to look to see what R's we have, resistances we have, because there's no calculation in those. So with the table done out, the very first element that I'll put in, or the component that I'll put into the table, will be the R. And if there's 2 or 3 of those there, straight away you're getting marks for putting each of those in, and there's no calculation required any of them at all. And then just, some people like to do an elemental table, or an elemental drawing, or sketch. I don't bother with that much. I just list off each of my elements as I'm going down, and there's normally a picture with the question which will show you each of the elements as they're placed on away. So straight away, the internal surface resistance, no calculation required. It goes straight into the R, and you can see that in the question as well too. It shows it there. I'm just listing off each of my elements as I'm going along there. The sand, cement screed, concrete floor slab, DPM, sand blinding, hardcore, and subsoil. And that completes the components of the table. Then all I've got to do is, from the question here again, is take each of my elements. So working down the table, if I go to the sand cement screed, I can see that I'm given a resistivity value for that, which is 0.170. Now I can work through the conductivity values that have been given here. The rest of them are all conductivity values, have no other resistivity values, so I just enter each of these here as it is on the table given in the question. And then I have to go to my thicknesses. Just be careful with your thicknesses that you make sure you convert them correctly to meters. I've gone through that there in another video. So straight away, putting in 60 millimeters, 100 millimeters, and it's 2.5, I think it is there, for our DPM, not much thickness in it. We've got our sand blinding of 50 millimeters, our hardcore of 225, and our subsoil of 300. So now I have all my values entered in there. I need to do a bit of calculating. So we go back to what I highlighted at the start here. Resistances can be calculated in either of those two methods. I can multiply my resistivity by the thickness, which will get me the resistance, which I'm going to do here just for demonstration purposes. Multiply that out, put in the value 0.0426. Now if I wanted to, I could convert the conductivity into a resistivity. And I just take 1 and I divide it by 0.16 and it would get me my resistivity, and then I could multiply it by the thickness. But just a quicker way of doing this here is where you'll take your thickness of 0.1 divided by 0.16, it gives us our value of 0.625. I'm going to complete the rest of them in the same manner here by taking the thickness and dividing it by the conductivity. Just be careful to make sure that you have the correct number of decimal places. It's quite simply a matter of being accurate with your figures now, putting in your thickness, dividing it by the conductivity, entering it into the resistance in the end. Now, where it gets very, very big here, we can reduce it down to maybe 4 decimal places. So if I want, what I can do here is just go back to this here again, 0.169, and if I wanted to take that 7 to put it up to a 2, that'll be fine. It'll not make a huge difference if a figure changes in the 4th decimal place. And as you can see that instead of continuing with the 6's, I just brought that up to the 7. So add up each of your values to get the overall resistance, total resistance. So we take our total resistance of 1.421, which I highlighted at the start, and I put 1 over that, which basically means I take 1 and I divide 1.421 and it gives me a U value of 0.7037. If I want to shorten that, I'll just bring it to 3 decimal places, and because it's a 7, I'll bring it up to the 4, bring the 3 up to the 4. And that's in the value of watts. The units of measurement is watts per meter squared degrees centigrade. And something I always like to do is just highlight the answer at the very end. That's our U value table, part A.